So, gentlemen, this is hopefully going to be a short announcement video because, well, if you're not new to the channel, you know that I usually tend to rant for an hour past the finish mark, so there's that. I want to modify the mini-lathe. As you can see, I'm lacking any real threading ability or capacity on this lathe. And while the lathe has the facilities, or rather the lead screw / feed screw required to do so, and the mechanism within the headstock, I am lacking gears to generate appropriate gear ratios. I do, on the other hand, have this automotive timing mechanism from a head of an engine that keeps the intake and the exhaust valve rods turning as they should. So I will use most likely this piece over here that has already been pre-turned to generate two, how do you call them? Not really sleeves, but adapters, one which will thread onto here and another which will thread onto here, which will have some sort of a I might even yeah, never mind. I'll give them most likely circlips or something like that to retain the pieces over them. I'll of course key them because the automotive means that they have keys. I'll simply mill the keyways in with the mill. So that's that. I'm also going to change out the hand wheels because these small hand wheels, although they are cute and made out of bronze, which makes them quite old-timey and appealing in that manner, they're a fucking bother. They're very small, they're uncomfortable to use. The handles constantly keep unscrewing. This one I have remade in inox, as you can see, but the wall thickness over here and the length rather of the threaded portion is not long enough to set a set screw in there. This one sticks out, as you can see as well, but at least it retains this one. The tailstock is also fucked, as you can see. Its key is not really operational. The bore has been bored, well, crooked in a sideways manner. So when it's properly aligned, it's slightly like this. This is obviously for demonstration purpose, but it does not sit straight. Nothing is properly done on this lathe. Everything is quite nice. The casting is quite nice. It is quite rigid. This portion is also a bit fucky because it constantly eats up chips and well, they protrude. So when you drag the tailstock over this section, it picks up and shears off the chips. I mean, it doesn't, but it could if one was reckless enough. So yeah, the lathe requires quite some work. It's a really decent piece for a very small lathe, but at the same time she has quite some flaws, not to even mention this lead screw nut mounting solution, which is the bottom of the carriage, which is an L bracket in steel, which really is no decent solution for the job that it has to do. So yeah, I'll remake all of that. For now, I have started doing work regarding this hand wheel because it's the main hand wheel that you're constantly using to feed, because the lathe does not have a rack to operate the carriage and move it back and forth. So this is the current, how do you call it? Well, where we are at the moment, at least. I'm also making a bronze plain bearing I'll have to put it on a mandrel, reduce the outside diameter. This diameter I'll have to mill off most of this, leaving only, you cannot see shit, give me a second. Mill it like this, leaving without it being tapered like the fingers do. Leaving two dogs parallel, which will sit over here inside. I will also mill, I'll just plunge an end mill in a line, so a mirrored keyway. This will fit into that, and that will also fit over, you can see the tapered pin over here. I will smack it out. I will drill the tapered hole out with a series of small step-up progressive drills up to 3 millimeters, and I will insert a needle-bearing needle into it, and the needle will also be of the same width, diameter, as wide as this will be, and as wide as the keyway will be milled into here, so 3 millimeters. And all of that will ensure that things are driving properly, and the bearing wheel, of course, will ensure that there is no contact with the steel of this adapter piece with the cast iron over here. I have considered even putting 2 O-rings into here, because this has a very slight clearance over this. It seats over here. I will give you a photo. I do not plan on taking this apart currently, just to keep the chips out, but the clearance itself should really keep the chips out. The O-rings would be better used to keep the oil in, because as you oil it, the oil leaks out of both sides of the bronze bush that the lead screw is turning in. So this portion would at least cap some of that oil, and I would have to remove it every now and again to allow the oil to just piss off, because it would be over time contaminated with bronze that would be polished off on this cast iron piece. And you get a point, just to remove the contaminated lubricant and to wash it out. But yeah, it would primarily be used to cap the oil inside the hollow, and to permanently lubricate this plain bushing, bearing, however you want to call it. So that's step 1, and this is where we are currently. The things have turned out really nice. As you can see, this chromed shaft, it was a hydraulic shaft. Give me a second. At least I assume it was. It being tool steel kind of makes no sense. I thought that it was tool steel of sorts originally before I blued it, because I did not realize that this was chrome. It was turning spectacularly and was producing a mirror finish like this chromed section. Well, let's call it a mirror finish. You can see from the striations in the bluing that it was not really a mirror finish, but it's a very fine finish as is. So I thought that it was tool steel of sorts. Let me just not drop this part. That kind of has the priority over framing. But once the chromed section was revealed during bluing, what else could it be other than a hydraulic rod? So yeah, it at least looks fucking spectacular. I'll give it that. And given that it is quite large, it most likely isn't just a regular structural steel. How would you call it? Medium carbon steel. Because larger hydraulic cylinders are actually decent carbon steel on the inside as well, just not truly hardened, merely semi-hard to keep them elastic, to keep them from shattering, maybe better said. I have tapped that piece and given it this original Zinger handwheel retainer, which at least does not allow the pieces to fall apart. or to slide out of each other for now while I'm handling it. But that will not keep things tied to the lead screw, so I'll have to take out the lead screw, flop it through the headstock, drill it from the rear, tap it. I'm tapping and die cutting all the threads because, well, as said, no threading capacity. But I will thread it and give it something like this automotive. I will polish it out. For fuck's sakes, I'm constantly kicking this hammer, which is holding the door so I can actually move over here. I'm sorry. Bloody retardation. But yeah, I will most likely polish this off. I could oxide it as well, give it well, you cannot really see it, but the inside and the other side, the face that is contacting the hand wheel, has that a really nice goldish, but not straw, hay, yellow. When you go past it near the 283 degrees, you get this orange, purplish, beautiful color, hue, however you want to call it. I might give that hue to this piece because it is a hardened automotive fastener, so I do not really want to go overboard and ruin its temper too much. I want it to remain as it is for the most part, but I will give it some color, and I will dunk it in oil and heat it a few times to cure the oil on it, just as I did with this part, to seal the oil in the oxide and to prevent it from rusting. So that will look quite beautiful as well. It's a regular Torx 6mm. That will be more than good enough to just pull this onto the lead screw and to retain it, because the key will be driving it. This is just keeping it located. But yeah, that pretty much does it. This is where we are at the moment. I have covered everything. I have said everything that I want to say pretty much. I could go into a rant about a tool post design that I have thought up, but I guess I will leave that for another video. I do not want to make, or rather turn this into a 20-minute video. So I will pretty much end it here. I'll just give you a glimpse of this Thiel Conturex indexing head, which is a project also in the making. As you can see, I have opened it up. This is its base plate, however you want to call it. It's a really nice piece and the foundational accessory of this machine, but given that the machine does not have its head, which turned this piece into a foundational accessory, and given that I will be using it in a completely different manner, I will restore this head and I will use it on my milling machines. Unfortunately, as you can see, it was designed for a vertical table rather than a horizontal one. So I guess a decal or a Schaublin 13 with a vertical table could use it as it was intended to be used. But I will only be able to use it well, on a horizontal table, because both the Emco, the Schaublin and Weisser mill outside have exclusively horizontal tables. But at the same time, most of the indexing headwork that I want is keeping a fourth axis, a turning lathe axis on the milling machine for cutting gears and different crap like that. But yeah, anyway, I'll shut up. I will bid you all the best until I post the video. Unfortunately, it's taking a while because I'll have to wait for the bearing supplier to open until Monday, and yada yada. You get a point. Things are taking time, as they always do. So until I finally post the full video, this will do as an announcement. I bid you all the best, and until then, bye bye.